Good morning, students. We have already discussed about Rutherford's model of an atom. According to Rutherford's model, the negatively charged electrons revolve around the positively charged nucleus containing protons in circular paths called orbits. In order to explain why negatively charged electrons do not fall into the nucleus on account of attraction, Rutherford had suggested that the centrifugal force due to movement of electrons balance the force of attraction. But the nuclear model of Rutherford fails to explain the stability of atom and the existence of large number of lines in the spectrum of atomic hydrogen. Now we will discuss how Rutherford's atomic model fails to explain the stability of atom. We know that when a body moves with a constant speed in a circular path, its velocity changes due to change in direction. Since the velocity changes, so the body will develop acceleration. So, according to Rutherford's model, electron should also get accelerated while moving in its orbit. According to Maxwell's electromagnetic theory of radiation, a charged particle moving with acceleration always emits electromagnetic radiation and loses energy. Now we know that electrons move with constant speed, but when it revolves around the nucleus in a circular path, its tangential velocity changes, so electrons will undergo acceleration. According to Maxwell's electromagnetic theory of radiation, since electrons, which are charged particle, moves in an orbit with acceleration, so electrons will emit radiation. So it means that the revolving electron must also lose energy continuously in the form of electromagnetic radiations. The loss of energy in every revolution of the electron around the nucleus must bring it closer to the nucleus, and the electron ultimately falls into the nucleus by following a spiral path as shown in this figure. So in this case, it means that the atom must collapse. But we all know that atom is quite stable in nature. So Rutherford could not counter the Maxwell's theory. So we can say that Rutherford's atomic model could not explain the stability of an atom. Rutherford could not explain the existence of different spectral lines in the hydrogen spectrum. This Rutherford's model recommends that the spectrum of hydrogen should be continuous and should not possess discrete lines. We know that atomic spectrum is a characteristic of an element. The atoms of a particular element will always give a definite set of spectral lines corresponding to a definite frequency or wavelengths. According to Maxwell's electromagnetic theory of radiation, the frequency of radiation emitted by a charged body is the same as the frequency of its revolution. Since the electron is forced to move in a spiral path In Rutherford's model, its frequency of revolution and hence the frequency of emitted radiation should change continuously. Such radiation should produce a continuous spectrum instead of discrete one. But the observed spectrum of hydrogen is not continuous. It contains a large number of well-defined discrete lines. Thus, Rutherford's model could not explain the spectral lines of hydrogen. So we can conclude that Rutherford's model fails to explain the stability of atom as well as the spectral lines of hydrogen atom. Let us discuss the discovery of the fundamental particle neutron. Until 1920, an atom was supposed to consist of only two fundamental particles, electrons and protons. Since electrons have negligible mass, the entire mass of the atom was regarded as the mass of the protons only. Each proton has a mass of 1.67 into 10 to the power minus 24 gram, which is taken as 1 unit mass. In 1920, Rutherford found that except for the hydrogen atom, the atomic masses of no other atom could be explained by protons and electrons only. For example, the helium atom has 2 protons in the nucleus and 2 electrons in the extranuclear portion. Therefore, the mass of the helium atom must be twice the mass of the proton, but its mass was actually found to be 4 times the mass of a proton. To solve this problem, Rutherford predicted the presence of some neutral particle in the nucleus of the atom, which has a mass equal to that of the proton but has no charge in it. So according to Rutherford, the nucleus of helium atom had 2 such neutral particles. These neutral particles were discovered by James Chadwick in 1932 during the study of artificial transmutation. Chadwick observed that when a thin foil of beryllium is bombarded with fast-moving alpha particles, beryllium is changed into carbon, and a neutral particle having mass almost equal to that of the mass of the proton and charge 0, that is neutral charge, was obtained. This particle was also obtained in several other nuclear reactions. This new fundamental particle was named neutron on account of its neutral nature. So, neutrons are electrically neutral particles. The mass of the neutron is nearly 1.675 into 10 to the power minus 24 gram. Neutrons are highly penetrating in nature. Neutrons are unable to ionize a gas. The discovery of this fundamental particle, neutron, helped a lot in accounting for the masses of atoms. We know that the nucleus of an atom, except that for hydrogen, consists of both protons and neutrons, and both these particles contribute to the mass of an atom. Let us discuss atomic number and mass number. Now, what is atomic number? Atomic number is the number of protons present in the nucleus of an atom. We know that an atom is electrically neutral. So the number of protons is equal to the number of electrons. So atomic number is equal to number of protons or is equal to number of electrons. Henry Moseley in 1913 tried to determine the exact number of positive charges present in the nucleus of an atom. By studying the nature of X-rays emitted when different elements were bombarded with cathode rays. He stated that the number of unit positive charges present in the nucleus of an atom is known as atomic number of the element. It is denoted by Z. Now, we know that all the protons are present in the nucleus and each proton has one unit positive charge. This means that the atomic number is equal to the number of protons in the nucleus. Moseley studied the wavelength of the characteristic X-rays by using a number of metals as anti-cathode. He found out that the frequency of the X-rays produced in this manner was related to the charge present on the nucleus of an atom of the element used as anti-cathode with the help of this equation. This is root over mu is equal to A within bracket Z minus sigma. Now this mu is the frequency of the X-ray, A is proportionality constant, sigma is known as screening constant, and Z is the atomic number. So Moseley gave us the concept of atomic number, which is equal to the number of protons present in the nucleus of an atom. Now, what is mass number? Mass number is the sum of the number of protons and number of neutrons present in the nucleus of an atom. Now, atomic number is represented as Z and mass number is represented as A. Now, the number of neutrons will be equal to mass number minus atomic number. So, this much for today. Thank you.